This is a model of a superluminous supernova, an exploding star brighter than anyone could explain, until now. And it all comes down to a mysterious wobble. Supernovae are colossal explosions triggered as ancient stars come to the end of their lives. Scientists have done huge amounts of work trying to identify and understand these cosmic fireworks. But in the last 20 years or so, astronomers have spotted some supernovae that don't make sense. Superluminous supernovae are 10 to 100 times brighter than expected, and no one is quite sure how that's possible. One idea is that shockwaves from the exploding star are heating the gas and dust around it, and that magnifies the signal from the blast, making it look brighter. Another theory is that these super bright supernovae have an additional power source charging them, like a hidden internal battery. That battery could be a magnetar, the spinning, super dense remnant of the exploded star. Its enormous magnetic field could pump energy into the material ejected by the explosion, making it glow super bright. But it's been impossible to tell which of these two scenarios is happening. Now, for at least one supernova, named SN2024 AFAV, we might have an answer. That's because this eruption appeared to wobble, but in a very precise way. In the months after it was detected, its signal brightened and then dimmed slightly before fluctuating, up and down, faster and faster. Like detectives, a team of researchers set about trying to explain why. The existing theories alone couldn't make any sense of what they were seeing, so they had to get creative. This was their idea. What if there was a magnetar, one the size of Manhattan, and it was supercharging the ejector around it? But around that magnetar was an enormous disk of material, up to 10,000 times bigger than the magnetar it surrounded. This cloudy disk could be thick enough to block some of the light from the explosion, and if this disk were at the right angle and rotating around the magnetar, it would alternate between blocking our view of the explosion and scattering more of the light in our direction, creating this wobbling signal. And if this disk falls in towards the magnetar, it would spin faster and faster, explaining why the frequency of the wobble, at least as seen here from Earth, increase over time. This is the first time that astrophysicists have spied evidence of this kind of spinning disk effect. And if it's happening, one explanation for that could be general relativity. Relativity says that space-time around the super heavy spinning magnetar can be dragged around with it, so that the disk spins too. This lens-tearing effect has been observed affecting satellites orbiting Earth. If the team is right, and this effect is causing the wobbling superluminosity, then this kind of supernovae could be a new and extreme playground in which to test general relativity. The spinning disk theory might even explain similar but less pronounced wobbles seen in other superluminous supernovae, strengthening evidence that magnetars are what power at least some of these super bright events. With the new Vera Rubin Observatory being expected to spot dozens of similar events in coming years, this theory could very soon be put to the test.